Okay, looking at the second part of this Unit 1 study guide, if we're looking at what can shift these production possibility curves, again, because when we're looking at these PPCs, we're looking at a snapshot of what this factory or this business is capable of right now, the different combinations that they could produce. If we're looking at shifting that curve outwards or being more productive, or shifting it inwards and being more productive or less productive, then what we would see here is some kind of change, right? So the three big things that could change a production possibility curve would be the availability or the quality of resources. So if you're looking at the Gulf War, the Iraq War, when we were in Afghanistan, right, and the Middle East, put these embargoes on us or limited their supply of oil to us, that generally shifted these production possibility curves inwards. We're able to produce less of everything because we need oil and gas as a resource in order to produce. Having better quality resources does the same thing, right? If we're looking at better quality oil, it takes less time to refine it. It makes it cheaper to use. If we're looking at technology, that's going to be the big one, right? That if we're looking at Henry Ford and the assembly line, creating this new way of doing things, creating this new type of technology, allowed us to produce more of everything, right? If you look at Papa John's, they use an assembly line to produce their pizza. If you look at auto manufacturers, they use assembly lines to produce their cars, right? That would shift that production possibility curve outwards. And then finally, trade, right? Trade in theory makes everybody better off. If we're able to get cheaper tomatoes from Mexico or cheaper iron from Canada, then we're going to be able to produce more of these goods. So the three things that could shift this production possibility curve, the availability of these resources, the access to technology, and trade. So if we're looking at these three, this one's going to be a little funky because I just drew on it. A recession causes unemployment. It's asking us to show this shift here. Now, the first one's kind of a trick question because if we see unemployment, that doesn't make us less productive, right? We would just be producing somewhere inside of this curve, right? Because if we were fully productive, if we put those people back to work, then we'd be back on this line here. Now, if it were to say that, a disease wiped out half the population, that would shift the production possibility curve because those people are no longer able to work. I know that sounds kind of morbid, but if we're looking at unemployment, it wouldn't change our capability of producing, right? If I have a factory and half of the workers quit, that doesn't mean that my factory can be any less productive. It just means that I'm inefficient for the time being. If I hired new workers, I'd be back on that line. Same thing for number 12. If consumers want more pizza, that doesn't change our ability to produce pizza. Let's just say we start out at point A. All that would probably change is that we move along this curve to point B, right? We're producing more pizza, in which case we'd have to give up some of those cars. The one that would shift would be 13. So more resources to produce cars. All right, let's say that we get new mines of iron and aluminum and nickel. That's going to make us able to produce more cars, but it's not really going to affect our ability to make pizza. So this PPC would shift outwards, but it would just be for the cars because the resources to make the pizza hasn't really changed. Now, if we're looking at absolute and comparative advantage, this is one that y'all are having a little bit of trouble with, so let's take our time with this. The table shows the amount of sugar and cars each country can make with the same number of resources. So our resources are fixed, so we're measuring the output here. We're measuring the amount of sugar and we're measuring the cars. So this would be an output question. Which country has an absolute advantage in sugar? With an output question, higher is better. If Mexico can make 50 sugar and Cuba can only make 40, well, Mexico would have the absolute advantage in making that sugar because they can make more than Cuba can. If we're looking at the absolute advantage in cars, it would be Mexico again because they can produce 100 and Cuba can only make 10. If we're looking at the per unit opportunity cost, Cuba's opportunity cost of producing one car, this is where we get into our acronym, OOO or OO. For an output question, the opportunity cost goes over what we're producing. So it's asking for the opportunity cost of producing one car. If I produce cars, my opportunity cost is going to be these sugars. I'm giving up 40 sugars. So for an output question, my opportunity cost goes over what I'm producing. The 40 cars is going to go over the 10 sugar. In which case, one car is going to cost me 4 sugars. That would be our per unit opportunity cost. One car is going to equal 4 sugars. The next is asking is which country has a comparative advantage in cars and which has a comparative advantage in sugar. With that, we need to figure out the per unit opportunity cost for these others. So let's start over here. If Cuba produces the 40 sugar, they're giving up the 10 cars. So that's our opportunity cost is those 10 cars. Sorry, that should say sugar. And that should say cars. So they're giving up the 10 cars. They're producing the 40 sugar. So 1 sugar is going to equal 1/4 of a car. And again, they'll always be reciprocals of one another, right? 1 car equals 4 sugars. 1 sugar equals 1/4 of a car. If you multiply these by each other, they're just going to equal 1. If we're looking at Mexico, they produce sugar. They're going to have to give up 100 cars. So up on top, the 100 cars, they're giving up, they're producing 50 sugar. So 1 sugar is going to cost them half of, sorry, where did I mess up? Yeah, 1 sugar is going to cost them 2 cars. If we're looking at Mexico, they produce 100 cars, they're giving up 50 sugar. So that's our opportunity cost, the 50 sugar, over the 100 cars. So in that case, 1 car is going to cost them 1/2 of a sugar. So to find out our comparative advantage, we're looking at who has the lowest per unit opportunity cost. All right, if Cuba is giving up 1/4 of a car and Mexico is giving up 2 cars, then we would say Cuba has the comparative advantage. Even though they're not as good as Mexico at making the sugar, they're really bad at making the cars. So they're not really giving up much cars whenever they're producing the sugar. Whereas if we're looking at the comparative advantage in cars, Mexico would have to give up 1/2 of a sugar and Cuba would have to give up 4 sugars. So we would say that Mexico would have the comparative advantage here. They're giving up less sugar per car. So if we're looking at question number 3, for the sugar, the comparative advantage would be Cuba because they had the lowest per unit opportunity cost. For cars, it would be Mexico because they would have the lowest per unit opportunity cost. Identify the terms of trade that can benefit both countries. 1 car for how many tons of sugars? All right, so it's already given us the cars. We know we're looking at cars here. So if I'm looking at what would be a good deal for sugar, I'm going to look at anything between these 2 values, anything greater than 1/2 but less than 4. So 1 car for 1 sugar should work, 1 car for 2 sugars should work, 1 car for 3 sugars should work. So let's just try a 1-for-1 deal, right? So I'm going to say 1 car for 1 ton of sugar. Let's see if both sides are better off. Right now, Mexico's making the cars, assuming that they want sugars. If Mexico were to make a sugar, they'd have to give up 2 cars. Or they can trade and just give up 1 car. In that case, that deal works out for them. It's cheaper for them to trade. Right now, Cuba makes the sugar. If they wanted to make a car, they'd have to give up 4 sugar. Or they can trade and just give up 1. So that deal is good for them too. It makes it cheaper. So when you're looking at that terms of trade, you're picking a side and finding a value between those numbers. I could look at this side as well and say 1 sugar equals 1 car, and that would be the same thing. It should work as well. Now, for the input questions, the table shows the number of hours. We're measuring the hours here it takes to produce a ton of sausage and a ton of computers, right? So we're not measuring the number of computers or sausage here. We're measuring the number of hours it takes. So if we're looking at absolute advantage, a low value is good there. It takes Canada 2 hours to make a sausage, and it takes the UK 10. So we would say that Canada would have the absolute advantage in sausage. They can do it in less time than the UK can. If we're looking at the absolute advantage for computers, same thing. It takes Canada 6 hours, and it would take the UK 10 hours. Per unit opportunity cost, we do a little differently here, right? For an input question, because we're measuring the inputs here, the hours, opportunity cost goes under what we're producing, IOU. So we've got the 2 sausage, the opportunity cost will be the 6 computers. So 6 computers, the opportunity cost is going under what we're producing, the 2 sausage. 1 sausage is going to equal 1/3 of a computer. And inversely, 1 computer should equal 3 sausages, right? The opportunity cost is the 2 sausages. We're producing the 6 computers. So by flipping the numerator and denominator, we're essentially moving it from an input to an output question. If we're looking at the UK, the opportunity cost is the 10 computers. We're producing the 10 sausage. So 1 sausage is going to equal 1 computer. 1 computer is going to equal 1 sausage. All right, so for 6, what's Canada's opportunity cost for producing one computer? We're going to look at Canada here, computers. One computer is going to cost them 3 sausages. Which has a comparative advantage in computers? I'll put C. And which has a comparative advantage in sausages? So we already saw that Canada, I don't know why I circled that there. If we're looking at the comparative advantage for the computers, if the UK wanted to make a computer, they would have to give up 1 sausage. If Canada wanted to make a computer, they'd have to give up 3 sausages. In that case, the UK would have the comparative advantage because they're giving up fewer sausages. So for computers, the UK would have the comparative advantage. So they're not as good at making the computers as Canada is. It takes them 10 hours, whereas Canada would only take 6. But they're also not that good at sausages either. It takes them 5 times longer to make a sausage than Canada. All right, now if we're looking at the sausages, Canada would have to give up 1/3 of a computer, whereas the UK would have to give up a whole computer, in which case Canada would have the lower per unit opportunity cost. So we would say that they would have the comparative advantage there. And as far as the terms of trade that would work for both of them, again, we're going to pick a value and pick a number between it. So it's 1 computer for how many sausages? Something between 1 sausage and 3 sausage should work, so we'll try 1 computer for 2 sausages. The inverse of that would be, or the reciprocal of that would be 1 sausage equaling 1/2 of a computer. Those would mean the same thing. So let's test this out. Right now, the UK is making the computers because they can do it for cheaper. If they were to produce a sausage, they'd have to give up a whole computer. Or they can trade and just give up 1/2 of a computer. So that deal looks good for them. Right now, Canada's making the sausage. If they wanted to make a computer, they'd have to give up 3 sausages. Or they can trade and just give up 2. So that deal would work for them as well. So a good term of trade would be 1 computer for 2 sausages. So anything greater than 1, less than 3, should work. Now for the last part of the unit, and we're going to touch on the implicit and the explicit costs a little bit later. But let's remember that the explicit costs are clearly stated, and the implicit costs are not, right? So if we're looking at, let's say that I want to open up a coffee shop. The explicit costs would be my labor costs, or my electric bill, or my water bill, or my rent, right? People that I'm going to be paying money to. If I have to write a check for it, it's an explicit cost. Implicit costs, generally what we're looking at is the opportunity cost, right? That if I open up a coffee shop, I don't think I'd be able to be a teacher full-time, right? So by doing that, I'd be giving this up, right? And I'm not writing a check to anybody, but the wages that I would lose, the enjoyment that I would lose, like that is a real cost too. So the implicit cost isn't clearly stated, but it still exists. So the opportunity cost of whatever decision that you're making. And we'll get into this a little bit more in one of the later units, so I'm not going to hit it too hard. The final thing of this unit is this utility maximizing rule. How do we make the most use of our money, of our resources? So what we're trying to do here is to get the marginal utility per dollar of one good to equal the marginal utility per dollar of another good, right? That if you have $100 and you like the movie Avatar, you're probably not going to go to the movies 10 times to watch that movie 10 times. You're probably going to go there once and go somewhere else after that, right? So the idea behind this is that we have diminishing marginal returns. The more we use of one product, the less enjoyment we're going to get out of it. So the scenario here it's giving us is that we can go to the movies or we can go on the go-karts. The movies cost us $10, the go-karts cost us $5. The first thing we're going to do is figure out the marginal utility per dollar of each of these. So the marginal utility of this first movie is going to be 30 units of happiness. We call them utils. Per dollar, it costs us $10. So we're getting 3 units of happiness per dollar. Now if I go the second time, I'm getting less enjoyment out of it. I'm only getting 20 units of enjoyment. It still costs me $10. So I'm getting 2 units of enjoyment per dollar. For this third time, I'm getting 1 unit of enjoyment per dollar. And for this last one, I'm getting half of a unit. Now, if we look at the go-karts, right, I'm not enjoying them quite as much, but they are cheaper. So if I go on this go-kart the first time, I'm gaining 10 units of enjoyment. That's my marginal utility. Again, we're looking at the marginal utility per dollar. The P is price. So the marginal utility is 10. The price of the go-kart is 5. So I'm getting 2 units of enjoyment per dollar. The second time I'm enjoying it less, I'm getting 1 unit of enjoyment per dollar. then I'm getting 2/5, then I'm getting 1/5. And so what this is having us do, this formula, is figuring out the best use of our money to get the most happiness, right? So if you have $25, what would be the best combination of go-karts and movies to maximize your utility? So I've got $25, so I can't do infinite numbers of both of these because of scarcity. So to try to figure out the best combination, right? If I'm looking at how I want to spend my first dollars, I could go to the movies and get 3 units of enjoyment per dollar, or I could go in the go-karts and get 2. I'll probably go with the movies, right? So we'll put a little tick mark there. All right, so I've spent $10 and I've got $15 more. All right, I can't go to the movies twice more. Could go on the go-kart 3 more times, in which case I would get 1 unit, 3.5 unit, 1 3/5 unit of enjoyment per dollar. Or I could spend that $15 and go to the movies another time and gain 2 units, and go on the go-kart once, in which case total I'm gaining 4 units of enjoyment per dollar. So the best combination, because now that marginal utility per dollar of both of them equal one another. So the best combination there would be the 2 movies and the 1 go-kart, because I'm spending 10, 20, 25. Now, if we have $40, let's look at how this combination changes, right? I'll spend my first $10 on the movie. Then it doesn't really matter whether I go to the movie, the go-kart, right? I'm getting the same marginal utility per dollar. So let's say $10, $20, $25. I've got $15 left. I can't afford to go to the movies twice. Let's say I go there a third time. So that's 30, 35. I've got 10 more dollars. Wait, no, 10, 20, 30, 35. Yeah, so I've got 5 more dollars. I'll go to the go-karts 1 more time. So now that marginal utility per dollar of the movies is equaling the marginal utility per dollar of the go-karts. So in that case, it would be 3 movies and 2 go-karts. And then finally, what's the total utility from consuming 3 movies and 2 go-karts? All right, so if we're adding up the total of 3 movies, the first time I go, I'm getting 30 units of enjoyment. The second time, I'm getting 20. The third time, I'm getting 10. So total, that's 30, 50, 60. And then if I go to the go-karts twice, the first time I go, I'm getting 10 units of enjoyment. And the second time, I'm getting 5 more units. That's 15. So if I add those together, my total utility would be 75, right? If you wanted to look at other combinations with this, right? Like let's say going to the movies less 1 time, but going to the go-karts twice instead. I would gain 3 units of happiness, but I would lose that 10. It wouldn't be worth it, right? So that marginal utility per dollar of one good equaling the marginal utility per dollar of the other, that's where we're going to be most profitable, most beneficial, the best use of our resources.